everybody, it's Mrs. Tremblay again with Lesson 4.5, Systems of Linear Inequalities. Please go ahead and make sure that you have a ruler, and you can use a pencil for this. We're going to be doing some shading, but honestly it would be a lot better and more clear if you had two different colors to use. So if you have two different colors of crayons or colored pencils or even markers, that would be great. I'm going to use yellow and blue because they make green when they overlap and it's very exciting. So go ahead and press pause, grab those items. Welcome back. Okay, system of linear inequalities. It's basically like a system of equations, except they're inequalities. There's not going to be an equal sign. They need to be in the same variables, and the solution to this is any ordered pair that's a solution of each inequality in the system. So there can be more than one. There's not just going to be one point. It's not just the one point where the graphs overlap. It's where the shaded portions of the graph overlap. So you're going to have multiple solutions with this one. Okay, and a little bit of review as well, because you have to remember how to graph an inequality. We'll put them together. I don't know. I think this lesson's a lot of fun, especially with the colors of it. Okay, so you need to know how to check your work, so we'll start right off explaining how to do that. To tell whether an ordered pair is an actual solution to the system, it has to, when you plug it in, make both systems or both equations true in the system. So let's say I give you this system, y is less than 2x and y is greater than or equal to x plus 1, and I say, is 3, 5 a solution to this system? All you would need to do is plug 3 in for x, 5 in for y, and see if it makes both inequalities true. So if y is less than 2x, then 5 should be less than 2 times 3. So again, I just plugged in the 5 for the y, the 2 for the x. Is 5 less than 6? Yep. So check, the first one's good. Let's check and make sure it works for the second. So y equals x plus 1. 5 should be, sorry, not equals, greater than or equal to, x is 3. Is 5 greater than or equal to 4? Yep. So the answer to this would be yes, 3, 5 is one of the ordered pairs that will satisfy both inequalities, because when you plug it into both inequalities, it's true for both. Now let's say I give you another ordered pair, because again, you can have more than one ordered pair that satisfies these. I want to know, is negative 2, 0 a solution to this? So start again. If y is less than 2x, is 0 less than 2 times negative 2? Is 0 less than negative 4? Sure isn't. So this right here, at this point, because this is not true, I don't even need to plug it into the other one, because it'd have to be true for both of them. I'm just going to give a big fat no for that. So negative 2, 0 would not be a solution point. So that's how you can tell if your answers are correct. You plug them back in. If it makes all the inequalities true, then it's a true solution to it. If it's not, even just one of them, if it doesn't work for one of them, it means it's not a solution. Okay, so now what I would like us to be able to do is to graph a system of inequalities. And to do that, you have to remember a few of our old rules here. First off, to graph equations, they need to be in y equals mx plus b form. And remember that when you're dealing with inequalities, if you have to multiply or divide by a negative in order to get that into y equals mx plus b form, you have to flip the sign. Step 2, once you've rearranged it, you're going to graph each line. Remember that if you have a greater than or a less than, it's going to be a dashed line. If you have a greater than or equal to or less than or equal to with that little line underneath, it means it's going to be a solid line. And of course, if y is greater than, it means you're going to shade the points above the y-intercept. And if y is less than, you're going to shade below the y-intercept. So once you've plotted both lines on this graph, you're going to have shading all over the place. The portions where the shaded portions of it overlap, those are the solution points. So it's not just any shaded part. It's the part where both graphs have been shaded. And you'll see what I mean in just a moment. All right, hopefully you have your ruler and your colored pencils ready to roll. Here's our first system that we want to graph. It's y is greater than 2x minus 3 and y is greater than or equal to x over 2 plus 1. Both of these are already in y equals mx plus b form, which is lovely. So let's just graph each equation. Y is greater than or equal to 2x minus 3. Remember that means that's a negative 3. So my y-intercept is negative 3. My slope, I'm going to put a 1 under it, means I go up 2, right 1, up 2, right 1. Now in graphing this, it says that y is greater than, so it can't be equal to, so that means I need a dashed line going on here. You go ahead and do that too, all the way across the graph. And if y is greater than, here's my y-intercept, that means I want to shade above for the greater than. So grab one of your colors, I'm going to start off with yellow, and shade this entire area in. You get to color, bringing back the memories. I love coloring. That's one nice thing about having little kids, is I can color anytime I want and no one will judge me. They just think, wow, she's so nice coloring with her children. I secretly love it. Well, I guess it's not a secret anymore. All right, the next one, y is greater than or equal to x divided by 2 plus 1. Y-intercept, yes, it's 1. And here some of you might look at that and need some reminders here. What on earth does this mean? Well, first thing you need to remember is that x is the same as 1x. So x over 2 really means 1x over 2. And if that still looks kind of funny to you, this 1x over 2 is the same thing as 1/2 x. So the slope in this one is 1/2. So from here you're going to go up 1, right 2, up 1, right 2. It says greater than or equal to. That means I want a solid line. So please make your line a solid line. And remember, we said that if there's a line underneath it that represents the solid line, if you don't see the line underneath it, it needs to be dashed. And y is greater than or equal to, right? So I'm going to grab my other color. We're only dealing with this solid line right here. Greater than or equal to means I want to shade the points above the y-intercept. So I'm going to shade this entire area here above that line. Don't worry about the stuff that's already shaded, just shade right over the top. If you're using a pencil, the part where you have double shaded is going to be a little bit darker than the rest. That's what you want. Okay, I'm hoping that you can see this here, that this little section right here is all yellow. And this little section right here is all blue. But this section right here where they overlap should look like a different color to you, or if you're using your pencil, this part here should be darkened. If it doesn't look darkened, you should darken that in if you're using a pencil. So this area here, where the shaded portions overlap, every single ordered pair located in this region represents a solution to this inequality. The portion here that's just yellow, that doesn't have a double shading, those are only solution points for that line. And this portion here that's only blue, those are only solution points for this line. With the system, it needs to work for both. So this large chunk here, where it's double shaded, represents all the solution points for both. In the directions it says, choose a solution point to check. And it's really important to make sure that you shaded correctly and to check all your solutions. So you can pick any ordered pair located in here. I will probably pick one that has a 0 in it because that makes it a lot easier. So how about, it looks like 0, 3 is in here, right? That's in the double shaded. So if you wanted to check the solution point 0, 3, all you need to do is plug it into both equations and make sure it's true. So x is 0, y is 3. First equation says that y is greater than 2x minus 3. So is 3 greater than 2 times 0 minus 3? Yeah, 3 is greater than negative 3, so it works for that one. With our second equation here, it says that y is greater than or equal to x divided by 2 plus 1. So is 3 greater than or equal to 0 divided by 2 plus 1, or is 3 greater than or equal to 1? Yes, it is. So that means we have shaded correctly. Sometimes we might shade below instead of above. This would allow you to catch that error. So that's how you check it. Pick any point in the double shaded region, plug it into each inequality in the system, and see if it makes both of them true. All right, next system. With this, they're not in y equals mx plus b form, but at least the y's are isolated already. So with this first equation, all you really need to do is add 2x to each side. So this one is really y is less than 4 plus 2x. I didn't have to change any signs because I didn't multiply or divide by a negative. And this equation, 2x plus y is greater than 4, all I need to do is add a negative 2x to isolate the y. So this would be y is greater than 4 plus negative 2x. All right, so let's graph them. They're in y equals mx plus b form. First one, y is less than 4 plus 2x. Y-intercept is 4. My slope is 2, and that means 2 over 1, so up 2, right 1, up 2, right 1. And it says that y is less than, that means it can't be equal to it, so I'm going to make a dashed line here. And if y is less than, that means that here's my y-intercept. I want to shade everything below that. So I'm going to start with the yellow. I'm going to shade this region here. I hope you're enjoying this as much as I am. And again, if you have your pencil, just do a light shading right now. It's fine. It's really good with markers. I think in class we'll have to use some markers. Okay? The next equation we have, y is greater than 4 plus negative 2x. So same y-intercept, it's 4. But this time I have a negative 2 over 1 slope. So down 2, right 1. Down 2, right 1. It says greater than, not equal to. So we're going to make a dashed line here. And just looking at this line, if y is greater than, that means I want the points above the y-intercept. So that means all the stuff over here gets shaded. To twist mine up a little bit more. These fancy twistable Crayolas. Alright. Shade, shade, shade. Okay, now in looking at your graph on your paper, I'm hoping that you see that this area is all blue. This area is all yellow. But this area here should look like it's a different color. It should look kind of green to you because yellow and blue make green. But every single point in this double shaded area represents a solution to this inequality. So I'm not going to check every single one for time's sake, but just know that you could choose any ordered pair in here. You plug it into each equation, each inequality, and make sure that both equations are true. I keep saying equations. You know what I mean. You know I mean inequality, I hope. So anything in here, plug it in. All right, let's keep going. Next example. Okay, one of them is already set for you in y equals mx plus b form. The other one, I have x plus y on the same side. We can rearrange that quite easily by subtracting x from each side. So y is less than or equal to 0 minus x is negative x. So here are my two equations. Let's graph them. Maybe some of you are already noticing something. If not, don't worry, you'll notice it in a minute. All right, so if I have negative x plus 4, that means y-intercept is 4. Negative x again means negative 1x, which means my slope is negative 1 over 1. So you should go down 1, right 1, down 1, right 1. Since y is greater than or equal to, that means I need a nice solid line here. And y is greater than, so that means that in looking at this line, I want to shade the points that are above the y-intercept, that are greater. So shade all those. Voila, I'm sure that looks nice and crazy on the screen. Okay, next one, y is less than or equal to a negative x. When there's no plus b, it means the y-intercept is 0. And negative x, again, that means negative 1 over 1. So I would go down 1, right 1, down 1, right 1. And since y is less than or equal to, it means I'm going to have a nice solid line going on. And since y is less than, when you're looking at this line, I want to shade the points below the y-intercept. So I'll get my blue. Or any of you thinking, what is happening? This is a crazy example. Maybe, maybe not. Maybe you're just coloring, enjoying the fun. Okay, So when you look at this, I'm hoping that you recognize those lines, they are parallel. When you rearranged your equations, we already saw those have the same slope and different y-intercepts. And you learned before, if we have the same slope and different y-intercepts, that's going to represent a special case. So the special case for this is that there isn't a solution. There's not an ordered pair that I could plug into each equation and make them both true. So in this case, I would write no solutions. And that's your answer. And you have your graph to prove it. So same slope, different y-intercept. If you have one is greater than, one is less than, hey, you're not going to have a solution. We could have shaded above, and in that case, you can end up having some answers to it. So don't just see parallel, oh, it must be no solution. With this, you need to do the graph to see where the shading takes place. Okay, I also want you to be able to write a system from a graph, and that's your next task here. It says write a system for the graph below. So I have given you a system. It's drawn out for you. I didn't actually draw this one. I found this one. I Googled it and found some images. So here we go. We have a nice shaded portion here. When you see a graph that represents the solutions, it's not going to show you the portions that aren't solutions. It's only going to show you the part where they double overlap. So in looking at this, if it double overlaps here, that means that this portion here was shaded and this portion here was shaded, but the only part where they overlap is that. So if it's your job to write a system for this, that means you need to write some equations of lines here. That's easy, right? That was all of chapter 3. You know what you're doing. So let's take a look at this solid line first. When you're trying to write an equation of a line, you need to know the slope and you need to know the y-intercept, right? Well, in this solid line, it looks like my y-intercept is -2. And I know there aren't any dots on this line, but the line is made up of an infinite number of points. So every single little part of this line represents an ordered pair. We usually just like to look for the ones that are whole numbers. So let's look for that. It looks like this is a whole number ordered pair, this one, this one, this one, all kinds of them. To get from one point to the next here, it looks like you're just going up one, right one, up one, right one, up one, right one. So that would make my slope 1, right? So the equation for this line right here, I would say is 1x, or just x, minus 2, or x plus -2, right? And we know it's y equals mx plus b because it's a straight line, but it's not y equals because it's an inequality. So I can put my y right here, and I need to know, is y greater than or equal to, less than or equal to, just greater than, just less than? So step 1, it's a solid line, right? That means it's going to be an equal to 1. So I'll put that solid line underneath. Now, if I was trying to figure out where this was shaded, if my solution points are in here, if you shaded above, you wouldn't end up in this little area. So you would end up having to shade below in order to be a solution point to this equation. So if you're shading below, that means that y is less than or equal to x plus -2. So there's 1 down. Now we have this dashed line right here. We need to figure out the equation for that. So for starters, it looks like that's my y-intercept right there, F5. And I see, it looks like a whole number ordered pair would be right there. So we make our own. If you don't see it, it's still there. It's just not a dot. Make your own dot. So to get from point to point, we need our slope now. You have to go down 3, right 1. That means my slope is -3. -3 over 1 is -3. So I would have a -3x plus 5. We have -3x plus 5. And it's a straight line, so I know it's going to be a y. Y equals something, but it's not equal because it's an inequality. It's a dashed line, so I'm not going to have the line underneath it. Now on this line, in order to be in this shaded part, that means I would have to shade this area here, which ends up being above my y-intercept. So this graph would be y is greater than -3x plus 5. So to write it as a system, we just list both equations. Y is less than or equal to x plus -2. Y is greater than -3x plus 5. What's nice about this, if you have a graphing calculator, or you could do this in class as well, if you don't have one, it's okay, or you can actually use an online one, you could type these into your calculator, press graph, and see if you're right. So we'll practice that one in class, or if you want to, practice it right now. Get your calculator, press pause, type in those two equations, and see, did you get this graph? Is this the graph that you got? Okay. It wouldn't be math story without a story time, right? So math story time, I want you to be able to write inequalities for situations. I know this is the tougher part. We'll do a lot of this in class and keep practicing, and eventually it's going to click if it hasn't already. So don't worry about it. Okay. So same kind of stories as you've had before, except we're dealing with inequalities right now. So you earn $11 per hour delivering pizzas. You also work part-time at a convenience store where you earn $9 per hour. I got this from my real-life experience going through college. Yes, I delivered pizzas. I worked at a ski and golf shop. I sold Avon. I subbed. You name it, I did it. All right, so 2 jobs. You want to earn at least $180 a week, but you can only work a maximum of 25 hours per week. How many hours can you work at each job? Okay. So you're given 2 rates here. You're given $11 per hour for pizza delivery. You're given $9 per hour for the convenience store. You're given 2 totals. You want to earn $180 total, and you want to work 25 hours total at the most. Would you have a problem if you earned more than $180? No. So at least $180 means it's not going to be equal to $180. That means that the amount that you make can be greater than or equal to $180. And if you can only work a maximum of 25 hours a week, that means you can't work more than 25 hours, but could you work 23 hours? Sure. So the value here, the reason it's an inequality is because if you worked less than 25 or equal to 25, that would be okay. There's more than one answer here. Okay, so you're given 2 rates and a total. I'm hoping that this kind of shouts out to you, ooh, standard form, ax plus by equals c. That's what's going on here. We know we need an x, we need a y. We can let our x represent our pizza deliveries, and our y can be our convenience store. And then we have our c's over here. So we have 2 c's given. Okay. One of these totals has to do with money, and the other just has to do with total hours. So if you're going to let the x represent the number of hours at the pizza place, and y represent the number of hours that you work at the convenience store, if you add your hours at the pizza store plus the hours at the convenience store, we can only get 25 or less. So this first inequality right here has to do with hours. I didn't need to include the dollars per hour because this 25 has nothing to do with money. It's just hours. So the hours at one place plus the hours of the other place can be less than or equal to 25. Now let's talk money. If we're going to talk the $180 that it's equal to, I need to include the $11 per hour and the $9 per hour now. So $11 per hour at the pizza place plus $9 per hour at the convenience store, I'm going to earn at least 180. That means it can be equal to 180. It can also be more. So there we have a system of inequalities that would represent this situation. If we were going to actually solve and work this through, which we will do in class, you could rearrange these into y equals mx plus b. You could graph them. You could create a table, and we would see, okay, what are some solution points for this? What are some hours that I could work at each job? Which we will explore tomorrow. See you then.